Hi everyone, this is John from Civil Center. Welcome to our channel. As we know, Civil Center is continuously working with the vision to guide civil engineering student and professional. So we have started about beam. So we have learned what are the different structural members, what is the load theory saying, and how the load is being transferred from the top to bottom. That means the complete load is transferred to the ground in which manner. So in that we have started the discussion about the beam. So in the last class we have learned what is beam, what are the different types of the concrete and the steel beams, and then we have learned about the forces. So whenever you are applying any load on any beam, suppose this is your beam and you are applying a load, that is the transverse load, which is acting perpendicular to the longitudinal axis on this one, then obviously some internal forces will develop. Now the question is, what are those internal forces? So those forces will be shear force and the bending moment. Now the question is how the bending moment is going to develop in a beam and how we are going to counter that. Okay, so suppose this is your beam and let's say this is the beam, okay, and you are applying a transverse load on it, then obviously a bending moment will generate in this manner. That will be other positive bending moment. Now since this beam is supported on the two sides, then obviously there will be a reaction force at the ends also, and over here the bending moment will generated in the negative way. That means the negative bending moment will be developed over here, and that's because of the reaction forces. So we can see at the ends we are having the negative bending moment, while at the middle we are having the positive bending moment. Now since the beam is designed, so we have to counter these bending moments also. So we will have to provide some extra reinforcement so that the beam can have the extra strength to counter these bending moments. So there is one way that you can provide the complete reinforcement starting from this end to this end, but that is not the correct way. Why not? Because if you will just provide a continuous reinforcement from here to here, and that is also extra reinforcement, then that will be uneconomical for your project. So to cut down that cost, we have to provide just the extra reinforcement. That means you are going to provide the extra reinforcement on the top, at the ends, and then in the middle at the bottom, because the bending moment is generating like this in the middle, and at the ends it will be generated like this. So to counter the positive bending moment, we are going to provide the extra reinforcement in the middle of the beam, at the bottom, and at the ends we will provide the extra reinforcement on the top. I hope this point is clear. Now then the question is, how much of the extra reinforcement should I provide? So what should be the length of that particular extra reinforcement. So for that we are going to see the structural drawing, and we will also see an example how the extra reinforcement is provided. So let's see that. So guys, you can see this is the longitudinal section of the beam. Okay, so we have to talk about the extra reinforcement. So you can see if this beam is discontinued on this end, then we will have to go for 0.1 L. Okay, and L is the length of the span. Then if it is continuous, then we are going to provide the extra reinforcement for 0.3 L. Okay, then the next important point is that this extra reinforcement, or you can say this length, should be considered from the end of the column. That means this column is provided over here, so we have to start measuring the length from here only. So we will measure the length of 0.1 L for discontinuous end, and for the continuous end we are going to measure the length of 0.3 L for the extra reinforcement in beams. Now in the center, that means at the middle portion of the beam, we are going to provide the extra reinforcement at the bottom. So for that we will provide the length of 0.15 L if it is a discontinuous beam, and if it is a continuous beam we are going to measure the length of 0.25 L. Now the extra reinforcement will be provided in the middle of these two. Okay, so we can just draw a line like this. This extra reinforcement will be provided for this length. Okay, So that is how we have to provide the extra reinforcement. So if I'm just going to draw it, then we will provide an extra reinforcement of 0.1 L on the top. If it is a discontinuous beam, if it is a continuous beam, we'll provide a length of 0.3 L. And if in the middle, we will just measure the distance of 0.25 L for the continuous end and 0.15 L for the discontinuous end, and we'll provide the extra reinforcement in the middle. I guess this concept is quite clear to all of you. Now here you can see some rod binders are binding the rod for the slab, and now they have already completed the rod binding for the beams. So you can see over here, from here to here, we have provided the extra reinforcement at the top. So like this, we have to provide the extra reinforcement. Okay, like from here to here, that extra reinforcement is provided. So guys, I think now you have already clarified your concept on how the bending moment is generated in the beam and how we provide the extra reinforcement at the ends and in the middle of the beam so that it can counter that bending moment. For more such informative videos, stay tuned to this channel, and if you have liked this video, hit the like button, share it with your friends and colleagues, and definitely subscribe to our channel and hit the bell icon so that you get notified whenever we release a new video. And if you want to start your career as a building consultant, then you will find a free webinar in the description. You can just go ahead, watch that free webinar, and you can book a free strategy session with us. Also, if you want to join our professional training, then you will find a link at the same place that is in the description. Go ahead, register yourself, and our team will connect with you. Thank you.